Hello everyone, welcome to the NN Classroom. Today, I'd like to share with you a past paper question related to our topic 7 in the chemistry syllabus, equilibrium, a really abstract physical chemistry topic in 2018 Time Zone 1 May paper. Question number 22. Let's see. What is the effect of increasing temperature? Increasing temperature is the keyword for this reaction. Going to be an equilibrium in which CO2 and water in equilibrium with proton and a hydrogen carbonate ion. A simple reversible reaction concerning how carbonic acid dissociates after CO2 dissolves in water, right? And one more important information, given that the forward reaction is exothermic, right? So remember, this is a really classical question asking for a really important principle in topic 7, the Le Chatelier's principle. Le Chatelier's principle states that all the equilibrium system will tend to change or shift the equilibrium position in a way to relieve the tension that we input to them. So what is the pressure or the stress that we input to them? In this case, will be increasing temperature, right? So that means the system will try to relieve this additional pressure. That means they want to reduce the temperature, in short, right? So that's why how do they reduce the temperature is actually really simple, by promoting something that absorbs the heat, right? So that's why in this case, remember, when temperature increase, the system will promote the endothermic behavior. That means they will promote a more endothermic situation. They will make the endothermic side that runs faster. So that's why the equilibrium position will shift accordingly. So particularly for this situation, given that forward is an exothermic situation, right? So that means not so surprised that the backward will be an endothermic reaction for the backward. So that's why as we deduce it, temperature increase, promote endothermic, and endothermic is backward. So in this particular case, we will deduce in this way. The backward reaction is promoted faster in this case, or simply means the equilibrium position will be shifted to the left-hand side. So for this perspective, first of all, you can already delete choice D, not to the right, but shift to the left to reduce the temperature. Try to, right? Yeah, and let's see the remaining. A, pH will decrease. B, pH will increase. Obviously, this is going to be an opposing statement, right? So that means one of them must be wrong and one of them must be true. Let's see further, right? In fact, where is pH related? Obviously, pH is related to the concentration of proton, H+, right? So where's H+? Here, on the right-hand side of this equilibrium, simply the product side. So if we deduce that the equilibrium position has pushed to the left-hand side, what we can deduce is that the right-hand side product will be minimized or will decrease in terms of the concentration, right? Including the proton concentration, because the proton is now positioned in the right-hand side. So that's why the concentration will decrease. So when concentration of proton decrease, remember, if we take the negative log, the pH will increase. Yeah, a really tricky part. A lot of people misconceptually think that, oh, lower concentration, lower pH. This is really easy to think in that way, but that is wrong. Remember, when proton is getting less, the pH is going to be increased. So that's why answer obviously goes to B. Double check it for C. CO2 pressure will decrease. Is it true? No. Why? Because CO2 is our left-hand side reactant. As we deduce again, the equilibrium position has moved to the left-hand side. So that means CO2 should have more than original. So they should occupy a greater pressure. So that's why CO2 pressure decrease. Wrong. So that's why obviously answers will be B.